whatever you took before. Now I'm going to click on it, so please don't pass out on me yet, because it's huge. 84 questions. But there are questions like this, for example, and with earlier class we did first three. So let's click on question 4. So that's what it looks like. That is a weird question. So let's read that together. If n is the set of natural numbers, w the set of whole numbers, z the set of integers, q the set of rational numbers, and I the set of irrational numbers, and r the set of real numbers, then determine whether the following statement is true or false. What the statement says, set of natural numbers is a subset of whole numbers. Now what do you think, is that true or false? Or that makes no sense?
True. False.
True. False.
True.
False? True?
True.
Well, what are natural numbers? What is the set of natural numbers?
1, 2, 3.
1, 2, 3, 4. Whole numbers?
0, 1, 2, 3, 4, -1.
Okay, so looks like every natural number is a whole number, right? So we're gonna say, hey, true, check. Nice. Gives you a little confidence boost as you answer those questions. So they're similar like that. For example, find the absolute value of negative 22 over 5. What is the absolute value of negative 22 over 5?
22 over 5.
Yeah, the way you're going to put in 22 over 5, you see on the left you have this little math symbol, so that looks like a fraction. I'm going to click on that, and I'm going to type in 22 and hit the, I don't know, I can do the mouse thingy, over 5. And check my answer, fantastic. And you see, you get a little, okay, you get a little green mark, okay? And you just go on. You don't have to do them in a row. You can just skip a bunch, do question 27 or whatever. Oh my God, look at that thing. Okay, so that's a little foiling problem. That tests your difference of squares technique. Is that right? Remember that? C plus 3, C minus 3. What that gives you? The C squared?
Minus 9.
Minus 9. So C squared minus 9 and C squared plus 9 will give you C to the 4th minus 81-ish. Check my answer. Fantastic.
What if you're wrong?
What if you're wrong? Very good. You're looking at this problem. Holy crap, I don't know. Oh my, I have to actually type in the answer. Okay? Do we get it? Did we get it? Well, do you want to just tell me what to type in? I'll type it in.
Z.
Z. All right. Z will clearly be wrong, right? Checked answer. So like, well, what? Notice that the product is in a special form, blah, blah, blah. You're like, well, clearly that didn't help, so I'm going to type in 3Z. And check that answer. It's like, sorry, that's different. And it gives you the same thing. Well, after you do it, I think third time, if you make another mistake, it will mark you wrong. It'll have a little red thing on top of it. You can still go back to that question and ask for similar exercises to rework it and get credit for it. But look at this little column right there. Let's ask this thing to, well, show me an example of what you're talking about here. So I'm going to click view an example. So this thing pops up. To begin with, notice that the product is in special form. Regroup the terms. So see, all they did, they threw a set of little parentheses around 3x plus 2y, 3x plus 2y. And what you realize is that these two terms only differ by a sign in the middle. Here you have a plus, here you have a minus. So it's kind of like the difference of squares that was shown previously. Does that make sense? Should make sense. So you see, this is a special product of this form. And if I continue, we know this formula. So in this case, a is 3x plus 2y. So actually, it gives you an example of sorts. And it continues through the steps, and here we go. Here we go, and here's the final answer for that example. All right? If that didn't help, you can ask this thing, help me solve this problem, so it will actually guide you step by step. Okay? So you say, okay, well, this is a squared minus b squared, and go down, so it will give you steps that you need to take. Okay? And after we're done, it will really So A is this. Good. So now ask me, how do you square 4x plus 2y, which is 16x squared plus what? 16xy plus 4y squared. Am I right? How do you know whether I'm right? Let me check. Oh, I'm right. Yeah? And so here we go. It gave you the answer. Now, the thing is, after it helped you solve this, when you click on close, the original problem changed. So you have to rework it without them help. But they'll guide you through the steps. So even if you're still confused, you can click on the textbook. It will. And this is our first time we're going to see our textbook, by the way. The textbook all of a sudden opens in the section that we need to review, which is section R3, polynomials. So you can actually go ahead and kind of look at what they're talking about there. You might be able to find an example that's similar to what we're dealing with. This is our textbook, by the way. It comes with little buttons like that. If I click on one of those buttons, I'll get this guy done. And by the way, you can do this or this. Yay! Spanish, you can do that.
We need to use the distributive property here.
And he'll talk for another 7 minutes.
2 is multiplied to the fourth y squared. We scan through here and we find another one here, x to the fourth y squared.
So you get that, right? So this is better than the regular book, because it will give you little exercises you can play with as you work along and stuff like that. If you're still stuck, look at this. Ask my instructor. You click on that thing, my email in there already. It will send you the link to this very question, and you can actually type in a question and click send. Yeah. Okay, so I'm going to get an email from you. Let me open that email. Okay, so here's my email. Let me log in. I'm still not that entirely. So here we go. I just got an email. Here's that question, whatever that was. Comes with the link. I click on that link. That very question that we were just looking at opened up. Okay, so I'll know exactly what you're looking at, what your problem is, and things like that. So I'll be able to reply to your question. Does that make sense? So this is pretty cool, actually. So when you're at home, you get all those extra tools to work on each problem, right? And these problems, I know there are a lot of them, but some of them will literally take you 12 seconds. Well, this might take you a little longer. Let's ask you to factor. Now, as we all know, the first rule of factoring is what? What do you do first when you're trying to factor? Anyone? Yes. Common factor. I want to take out the common factor. In this case, it's 9 and v, right? So I'm going to take, let me do this. What was the question? Does anybody remember? The question was 9vd to the fourth minus 9vk squared, right? So 9vd to the fourth minus 9vk squared, right? So the first rule, look for what's in common, which is 9 and the v. So I can take 9v out, leaves me with d to the fourth minus k squared. Is that okay? Now we notice how those two powers are even, so it's kind of like that formula that we saw earlier, difference of squares. So using the difference of squares formula, it will break down into this. So basically you divide each exponent by 2, 4 becomes 2, 2 becomes 1, and then you alternate the sign. So that's it, you cannot go any further. Alright? So if I put that as my answer, so what was that? 9v, open parenthesis, d squared, so that's a little square, plus plus k, and then d squared minus k, and I'll do that. Yeah, fantastic. Okay, really, still good. So, what do you think? Oh, this is fun. Yeah, my 099 students from not so long ago. Remember those problems?
No.
No?
Yeah.
Sure, you factor and then you cross common factor. That's
Talking about flip-flop?
yeah, well, don't flip flop, it's a product.
Yeah.
Yeah, don't flip flop, but factor and then start crossing everything out, right? I mean, do you want to, let's try this. Okay, I'm just getting crazy with my windows here. Here we go, yeah. And this is, I'm sharing my desktop with half of the country right now. And it's being recorded, so I have to wash my mouth. And so do you, actually. This is a powerful mic. So let's try this. So what was that? Well, my first, I should factor. I'm going to factor as I write. Can you guys see that? X squared minus 5x minus 14. How would you factor that? Two numbers that multiply to negative 14, but add to negative 5.
X minus 7x plus 2.
Very good. X plus 2. Now the denominator, I cannot see it, but it looks like, what happened to it? Here. Uh-oh. What does it say? X cubed minus 5x squared. So the only thing I can pull out is what? X squared? Is that right? That's the common factor. X squared leaves us with 7x minus 5 times 49x cubed minus 25x.
Take out a 7.
Well, 25 does not have a 7, but I can definitely take out an x, right? But look what happens when I take out an x. It gives me 49x squared minus 25, which is the difference of squares, right? Square minus a square. I'll keep that one in mind. Over 7x minus 49, I can definitely take out a 7 from that one. Right? Right away, I can cross two things out. Can I? What can I cross out?
X minus 7.
Okay, x minus 7. I can do one of the x's. I have x and x squared. So that x and one of those. Is that okay? But I can still factor this thing. So as I go further, so this is x plus 2 over x times 7x minus 5. I can factor that one. 7x minus 5, 7x plus 5 over 7. Right? What else can I do?
7x minus 5.
Yeah, I can do 7x minus 5. That's pretty much, that's it, right? So the answer, in the end, x plus 2, 7x plus 5 over 7x. Can I cross out this to 7x's? Very good. I cannot. I can only cancel through products. So since that has plus 5 next to it, they are not the same. Now the only question is, do I need to FOIL that numerator or not? Right? Because that's not clear. But when I look at this thing, the simplified product is, so I really don't know what they're looking for. So I'm going to type my answer the way I wrote it. Oops. Which is a fraction. Let's try this. X plus 2, and then 7x plus 5, all over 7x. Keeping fingers crossed. Nice. I'm almost certain if you FOIL that numerator, it will still give you the nice word. A lot of times it will say something in blueprint beneath how they want your answer to look like. Especially if it's a numerical answer, they'll say, round to the 3 decimal places. And if you round to 2 decimal places or 4 decimal places, they'll actually mark you wrong. So you have to be careful there. First time I've used the software that Math Excel was about 10 years ago, and it was really cranky. Let's say the answer was a half, and you put 0.5, it'll just mark you wrong. you know. But then now it has more flexibility. They put a lot of options for this because, you know, same answer can be expressed in different ways. So here we go. So does that make sense? That's, some of those are multiple choice. Oh, this is a fun one. Oh yeah. What do you think? It's almost a trick question, but I love it. What? -9. What else? 9. Okay, so there are really two options. So which one? 9? You want to vote? See, like, well, I need to get those, you know those clickers things? I can give you the, we have those clickers. I can just, yeah, we can go all kinds of high tech here. Use clickers. Let's vote. -9. Who's going to count?
I'm not confident.
Who's counting?
What?
About +9. So -9 is clearly winning. Who's kind of thinking it's neither? Alright, so -9 then. Alright, so what do you think the answer is?
It's 9.
9? Now, two reasons to think about this. Order of operations. You go from the inside out. You square first, that gives you +81. Then you take the square root, that's +9. One thing you need to remember, the square roots always produce positive results. Square root cannot be negative by its definition. We actually have a rule that says something like this. And for my 099 students from not so long ago, I'll be picking on you, because you've seen them. Oh, they're not listening to me, they're hiding their eyes. You've seen that rule before. When you take a square root of a number squared, it always comes out as absolute value of that number, for the reasons that square roots cannot produce negative results. Does anybody remember the graph of the square root function? That's okay. No, not problem. That's the square. Yeah, well, no.
No?
Never mind.
It's happening.
Well, I'll go over that in greater detail as we progress. You don't need to know the graph of the square root function. But looks like that Nike symbol. It's like if you take a parabola half by half and then drop it on the side, it looks like this. So it's in the first quadrant, always positive. It's positive x, positive y. So that first quadrant. Always positive. So square roots can never produce negative answers. Okay? We'll talk about that because there are some technicalities that usually confuse students on. Anyway, so. And there are some real fun ones with the square roots and rationalizing the denominator and things like that. You know what I'm talking about here? Rationalizing the denominator. We don't like to have square roots in the denominators. So you can ask to give an example and it will blah, 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 blah. You see how pretty that looks and how ugly it was when we started. Okay? So this thing is really good if you use it. So you have to use it. You have to try those little things, because they're just right there. And I think it should be pretty almost all platform friendly. Mac, PC, iPad, I don't know. You might even do it on your cell phone. But which is one of the reasons why we are not allowed to use cell phones on the exams as a calculator. Get a calculator. Okay? If you don't have a calculator, actually, you got, well, I'm not going to tell you. You're out of luck if you don't have a calculator. But, well, I can lend you one, probably a scientific. If you want a graphing one, you can probably still buy it. You don't really need a graphing calculator. There are options. Again, on the web, you can find a free graphing calculators on the web. If you're on a Microsoft machine that runs Windows, that was a redundant statement, but it actually comes with a math tool that is a graphing calculator. It looks like a graphing calculator. It does everything that a graphing calculator does, plus some extra options. And it's free. It's part of your Windows. Okay. When we used to have a dollar store here in town, you can buy a scientific calculator for $1. It was a scientific calculator with sines and cosines and trig on it. It'll last you through calculus, just $1. We actually tested it, it worked, matched the answers with the more expensive calculators.
Then how come I paid like $75?
Well, because you bought a fancy graphing calculator.
Oh, it wasn't a graphic.
Yeah, no, it was just, it was literally this big, but it was scientific. It had the trick buttons on it. It didn't have a brand, it just said calculator. So it was a calculator made by a calculator. It was awesome, but I was sad to see the dollar still go, just for that very reason, dollar calculator. I mean, you cannot.
Can't beat that price.
No. I mean, scientific, not just the one that adds and subtracts. I mean, it does everything. Well, except for graph. It doesn't graph. Okay. So does that make sense how you work on your homework? You go in, you click homework, and you can just click save at any point and leave and come back. You don't have to do it in one sitting, unlimited time, but I suggest, you do a few a day, because the 84 Pro, you cannot just crank them all in once. Your brain will start playing tricks on you. But that's the prerequisite stuff. And you score 70% on that, it takes you to homework 1, which is the real homework. We're starting this in section 1.1 in your book. And it covers first, well, apparently 4 sections in your book. And after you're done with that homework, there are quizzes. So quiz 1. In order for that quiz to open, you need to score 80% on homework 1. So that opens up that quiz. You can take that quiz. It will look exactly the same as the homework, only it will not have those extra help me solve this, show me an example, ask you instruction, fantastic things. You'll just do all the problems, you save, you submit it, and then you'll see your score, and it'll tell you what you did wrong. Okay? And you get 2 attempts at it. You do it once, you don't like it, do it again. Or you do it once, you really like it, you got 98, you want 100, do it again, you got 96, it's still 98, the highest score. So you get 2 shots per quiz. And the quizzes are part of your grade. Homeworks, they're just for you to learn and practice. Yeah.
Can we come to you for more attempts?
Oh, well, you can try. Yeah. I mean, clearly if you fail miserably one of the quizzes, we can talk. Now, ignore the exams. Exams are not for you, they're for online students. Leave out. You will be taking exams here in class. We'll review, handwritten, very traditional. Is that what you want?
I can take it.
Okay. Now, another cool little thing, study plan. After you work on these assignments and you keep making similar mistakes, this thing starts noticing the areas that you need improvement on, and it will create a personalized study plan for you. Since I was goofing around with this thing earlier, so you see like that little symbol means, hey, you need practice that. So if I click on that, it says, oh, you need practice things almost in every section, because, I was just, oh my God, look at that. It gives me all the practice things I can play with. And it has, what is this? Oh, you see like that little symbol? If I click on that problem, in addition to all the learning tools, it has a little animation. I don't know what's going on. I think it's loading something. It just throws random. Okay.
Change the expression to scientific notation.
Yeah, blah, blah, blah. Okay? Now, gradebook, it will keep track of how you're doing. I will be slowly moving these grades into your Canvas gradebook, but, you can check in both places. So right now I'm at 11% on the first assignment. Now, chapters, basically, that's your book. All right, so it has all the chapters in that book, chapter 6, whatever that is, section 6.4. Has video examples, your text, and the study plan. If you click on the text, basically, again, your book opens up on that very page, that section 6.3 or 6.4. That's actually from trigonometry. We're not going to cover that this semester. But, so yeah, that's your book. Really easy to get to. Now, it also has this, the multimedia library, that comes with a bunch of little videos and tutorials and factoring. Let's say we're bad at factoring. So let's see what they have available for factoring. A bunch of little animations. Have a video lecture, video podcast of people talking math. Okay? a secret. Don't tell anybody, because people just realize that, you know, I am obsolete. Look at this. You don't need me. It's all there. You only need me if you have a question that you needed to be answered like right away. You cannot go to the tutoring lab, which might still not happen right away. It's hard. But again, this is fast. I don't know why I'm not showing you. PowerPoints, videos. We got examples. Example 6. Whatever that is. You just have this guy talking again.
3x squared minus
And we can do
10x
Spanish or
Step
English.
1 is to look for a common factor.
It's pretty
The
awesome.
only common factors are 1 and or negative 1. And so we go to step 2, which is to look at the coefficient of the squared term, the 3, and look how that
Important, by
might
the way.
factor. The only possibility for the positive coefficients would be 3 times 1. So we would write this as 3x and as x. Now, you could have done it as x and 3x. Your eventual result would be the same, and we'll get into that as we go into our next 2 steps. The next step is to look at the constant. We need to find pairs of factors that multiply to give us negative 8. So let's begin by writing these down. We could have, for instance, negative 8 times 1. We could have positive 8 times negative 1. But we can also reverse the order.
Yeah.
Have.
You got the idea? Or you want me to keep playing? You know what he's doing? He's trying to trial and error his way out of that problem, by the way. He's not really factoring. He's just going to basically see which ones work. He's going to plug them in and then FOIL. Yeah. You know how to do it more scientifically? How do you do it more scientifically?
AC method.
AC method. Very good. Let's do that. I like more scientific thing here. What was the problem? 3x squared minus 10x minus 8?
Yeah.
So AC method. Remember how that goes. You multiply these two numbers. What does that give you?
24.
Only negative,
So,
right? So the product is negative 24. The sum is still negative 10. So the sum is negative 10. So can you think of two numbers that multiply to negative 24 and add to negative 10?
Minus 6, minus 4, or minus.
Or
3?
2.
8 and 3?
well, 8 and 3 will add up to 11-ish.
Negative 12 and 0.
Negative 12 and positive 2, that's right. Negative 12 and positive 2. These are the two numbers that will multiply to negative 24 and add to negative 10. Now, what do I do with those two numbers? That's the tricky part. We will rewrite this expression. We will split the middle term. Instead of writing negative 10x, we'll write negative 12x plus 2x. So basically, we're really unfoiling this thing. We're creating an, F is for first and L is for last, but then O and I, they usually mix together. So actually, we're separating. We're taking the outers and the inners out of that. So 3x squared minus 12x plus 2x minus 8. So we still have that negative 10x in the middle, right? We haven't changed anything. But then we're going to factor by grouping. Remember that wonderful technique? Look at the first two terms. What is the common factor between 3x squared and negative 12x? 3x. I'm going to pull the 3x out, which leaves us with x minus 4. Now remember, I need another x minus 4. That's how factoring by grouping works. So when I look at the last two terms, what can I take out? 2. So if I take 2, it gives me another x minus 4. Right? So x minus 4 becomes my new common factor. Right? So I'm going to factor out x minus 4, and then leaves me with 3x plus 2. So that's what that thing factors into. Right? Nice thing about factoring, you can always check by foiling, because you all know how to foil. That's the easy part. So if that doesn't foil to the original problem, we're doing something wrong. Yeah? You like that? I think that's better than what that guy was doing. So maybe I'm useful. bumming me out. But I think it's wonderful that you have all those things. And that's really all you need in this My Math Lab. If you just stick to the homework tab and the quiz tab, you'll be fine because they'll contain all those extra learning tools anyways. You know, if you come to class and things like that. Okay? It's pretty cool. So it comes with a book. The book has buttons on it. And it comes with all those extra things. And it's fraction of what the book costs. And I don't know. I don't know. Okay? So any questions? Yeah.
Where do you get the access code? Just on the internet site?
Yeah, if you just log into that My Math Lab place
Yeah.
and go to register, it will give you an option. Hey, you just want to buy it,
Yeah.
or you already bought it. So you just click buy it, and you can pay with a PayPal or whatever, or with a credit card. And you can actually, it should give you an option for temporary access. So you don't have to pay anything. It'll give you like a week or two to play with it, where you actually realize whether you're going to stay or withdraw or drop whatever. So it doesn't even charge you money. Even if you buy it, I think there's some kind of a refund policy. I'm not 100% sure about that. But you can do the temporary access. Okay?
Is there a quiz every week then?
Well, basically, if you look at the syllabus, then yes. It's basically every week, starting not this week, but the week after. The first quiz is due on the 8th, and then it's every week. There is no quiz on the day of the exam except for the final. If you look at the final, that last quiz is really silly. There won't be too many questions, and it's actually due after the final. It's due on Friday.
Okay.
But again, the due dates, those quizzes, they're open right now. They're available. In order for you to open quiz 12, you have to work through everything.
Okay.
So there, you know, if you want to get a head start, you can keep cranking them out. It's just the exams are kind of fixed, but you know, you saw those assignments. It's hard to go fast, but you can if you want to. They're already open, so you can do them early, but not later. Later would be a problem. Okay. Okay, good. Let me check something else. Well, actually, never mind. Any other questions? What else is here? I'm gonna take attendance today. I usually don't, but we have to do it during the first week for the no-shows and things like that. It's the new federal regulation. Blah, blah. So I have to do that. Attendance is not a part of your grading. You know, if you're not here, I don't even. You know, if you want to tell me why, fine. If you tell them, that's okay. You will have the recording of the lecture to watch later. You have all those extra videos to play with. You know. You're all adults. Just show up for the exam. That will be tricky to do. And those dates are pretty sad. I mean, if we decide to change those dates, we'll make a decision way in advance. Now, but again, those dates only for you for this class that meets Mondays, Wednesdays from 6 to 8, just in case somebody else watches this recording and gets confused. You all have your own syllabi. Now, the grade structure is pretty straightforward. You know, you total is 1,000 points, so this is the thing. You know, that's how your grade is going to be worked out. Okay, any other questions? That all makes sense? What am I forgetting? I always forget something important. Alright, well let's do some math then. Are you ready for some math? We're not going to be here much longer today. I want to show you just one thing to get out of the way. So, algebra. Just like any branch of science, whether it's biology or whatever, in math we have all other mathematical little branches. We have geometry, algebra, calculus, analysis, all that stuff. Now, algebra has its purpose, and the purpose of algebra is to solve equations. There's no other reason for algebra to exist. That's what algebra means if you translate it from Arabic in search for the unknown or something like that. That's the sole purpose of algebra, solving equations. Nothing else. So everything that we'll be doing this semester, no matter how silly it might look, the purpose of that will be to solve equations. Somehow, it will lead us to solving equations. We're not going to be graphing equation of a line mx plus b, whatever. Somehow that's solving equations. We'll realize that all ties together. Now, just to be fair, when I say equations, I should also include inequalities. Because then you might catch me on that saying, hey, inequalities are not equations, what do you mean? And you'll be absolutely right. But they're closely related. Okay? So that's what we're doing. And right now, I assume you know how to solve linear equations. No matter how crazy I might decide to make my linear equation look, you should be able to solve linear equations. If you like linear equations. Now, an example of a linear equation something very silly. Here. Can we solve that?
Yeah.
Tell me what to do. Oh, you already know the answer, you guys too good. How do you get there?
Subtract 1.
Subtract 1. Now what?
Divide by 2.
Divide by 2. Very good. How do you know whether that's the right answer?
Plug it back in.
Plug it back in. So when you check, when you plug it back in, it's 2 times 3 plus 1. Will that equal 7? This is my notation for I'm not sure yet, I'm just checking. Which is not mine, this is an official notation when you check. So you work out the left side, you hope that it looks like the right side, and then that's what checks, right? And that's what we're looking for. We're looking for a number that you can plug in for x that gives you that an identity. So that's, if I, for some reason, decide to give you a test right now that has 100 questions that all look like that, what should I expect from, why would you like that if I just give you a pop test? 100 questions like that. What do you think you would get on it?
100%.
Oh, come on. You will get, yeah, because at some point you'll just go 2 plus 3 equals,
I get lazy.
yeah, 4. I do that a lot, you know, something simple. By the way, watch out for that, because I'll just go 2 plus 3 equals 8 and it will ruin our game. But yeah, you'll get upper 90s 100, right? And so that's the good news. The bad news, that's clearly not what we're going to be learning this semester. This is not the level of this class. So that's kind of the bad news. But the good news, again, back to good news, that we'll try to take messy-looking equations, psychotic-looking equations, and make them into something like that. One big bad equation turns into 4 equations that look like that, which is okay. We can solve those. But then getting from a big bad equation to those little ones, that takes some work. And that's what we're really going to be learning. Those manipulations and approaches and algorithms, things like that. Okay? Good. Linear equation. The only way I can make this hard is if I throw fractions over it. That makes it a little funny. I'm glad you said that. Fractions are good for you. Okay, so let me really quickly do a rundown of those. Remember the very first question I clicked on, n is for naturals and W is for whole, whatever. I just want to review the whole structure of the real numbers so we're all on the same page. And those symbols or whatever. So the set of real numbers is usually, even if you took your prerequisite classes, you know, they might have not covered all the different sets. Now, first of all, that word set, in a mathematical sense, when we talk about a set, we mean just a collection of things, collection of stuff, which is things brought together, like this class. You're a set of students, okay? Now, so just like this classroom, the mathematical set has certain properties. So the definition that I like to use for a set is just a collection of stuff. Okay? So, there are two properties, really, that sets are unordered. I really don't care in which order I list things in the set. Like this classroom, I just send that sign-in sheet. I really don't care in which order you put your name in. I didn't want you to alphabetize it, breaking, male, female, height. I don't care. You can order it in any ways you like. As long as it's all there, I'm good, right? It's still a set of students in this class. And also repetition-free. Repetition, I forgot the free part. It's kind of important. So, for example, if Bob signed that sheet, I need Bob. Do we have Bob in here? Okay, Levi, did you sign that sheet?
No.
You shouldn't have. Good. So if we had a Bob in here, then, if Bob signed that sheet, I don't need Bob to sign it again. I get it. Bob is a part of the set. So, like if I have a number 5, that's part of the set, I'm good. I don't need another 5. I got it. 5 is a part of the set. Good. So, example, the way we write our sets, the set notation, usually use capital letters to denote. Set as the name of the set. And set A equals, we use those curly brackets, and then we just start throwing things in that set, whatever we like. So let's put things in there. What do you want to put in there? Infinity. Okay. What else would you like? 9. What else would you like? 2. Okay. What else would you like? X. I'm totally free of doing that. And if I put a 2 like that, and then another 2, and then one of those 2s, I haven't violated the repetition-free clause, because all those 2s look different. If you're from another planet and you look at that thing, are there all items look different? Yes, so it's repetition-free. Even though some of them might mean the same. Okay? So, 9 is an element of this set. Okay? 2 is one of those, well, all of them, elements of that set. So there's a special notation. If I want to say that 9 is an element of this set, we have a special symbol. That means element of or belongs to. So 9 is an element of A, or 9 belongs to set A. So that little symbol stands for element. How many L's are in element?
Just one. Yeah,
Seems like,
just one.
seems like 2.
There's 2 R's in unordered, though.
Yeah, I'm forgetting the important parts of the statements. Element of or belongs to. Now, is 7 an element of this set? No, so I'll just say this. 7 is not an element of. Okay? So that's a notation. Now, of course, the sets that we'll be dealing with will have numbers in it, most likely real numbers. Okay, so that's what we're focusing on today. So the first set of real numbers that we're going to look at is the set of natural numbers. Now, what are natural numbers? Those are your counting numbers. Now, what numbers you use to count? If you were to count students in this class, how would you begin? 1, 2, 3. You would not start at 0, right? You go 1, 2, 3. So 0 is not a natural number, but from 1 and on, positive whole numbers, those are the natural numbers. Positive whole numbers. So we use a special letter, capital N, with kind of a twist, kind of a double-legged N. Your book will just make a big capital N, but in some books they use that notation. So then I'll just lose the elements, and I'll just put dot, 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 which just goes on forever. When you give it some kind of a pattern, then you can just say, well, I'm not going to finish it, it just goes on for a while. There are some other ways to express that set, but that's it for now. So that's the set of natural numbers. 1, 2, 3. Probably the first set used by humans, as many that you can. Then we started doing fractions, because I needed to trade. Cow, goat, half cow, 1 goat, that thing. Negative numbers came in much, much later. And so was zero. Zero was all kinds of mess. It's much younger than some numbers. 1/2 is just, you know, way older than 0. But anyway. Now, but where do these numbers live? If you were to send a letter to 3, what's the address? Where does 3 live? You know where 3 lives? Well, but where does 2 live?
Next to 1.
Next to 1, but where is that whole avenue called? Well, it's that side, so that neighborhood, but the whole city where they all live. Real number line, that's right. That's where they all reside, right? So if I were to draw that real number line somewhere here, I'll try to fill it up, but for now I only got these things. You know, the positive whole. Now it's easier for me to now do the negative numbers. So those are integers. A set of integers. So those are just whole, positive and negative whole numbers. Your book will also talk about the set of whole numbers. Nobody cares about the set of whole numbers. It's made up. Same as natural, is only plus. But integers. So those are your, I don't know where to start. It goes negative, but then a few negative numbers. -3, -2, -1, 0, 1, 2, 3, da, da, da. Special letter that represents set of integers is a big Z with a kind of a twist. Okay? So big Z is the set of integers. And they also, so if I put them on this number line, okay. So in between you got fractions. Okay. Now please notice how every natural number is also an integer. So we actually say that set of natural numbers is a subset of the set of integers. So every element in here also belongs in there. The special notation for the subset, it's kind of a glorified less than or equal sign. You can picture less than or equal sign? I'm going to blow it up a little. I'm going to make it look like this. So it's kind of a upside, sideways U with a, so could be equal, but that stands for the subset. N is a subset of Z. That's what you saw when I was putting that exercise. Well, remember, I think it was the very question. N subset of Z, and we said true. Okay. Then we'll go on to set of rational numbers. Now, these are the numbers, these are your fractions. These are the numbers that can be expressed as the ratio of 2 integers. That's the official definition. In math, it's very important to have a definition. So numbers that can be expressed as a ratio of 2 integers. Okay? Give me some examples of such numbers.
1/2.
Sure. 1 half. Give me another one.
3 halves.
Okay, 3 halves. Give me something that's a little more interesting. Can it be negative?
Yeah.
Sure, because it says ratio of two integers, integers can be negative, so sure, I can have a negative 4 sevenths, right? That's rational. And you see, now I'm really ignoring the order, I'm just throwing them in. This is nice. I don't have to put them in order. How about 5? Is 5 rational? Yeah, can I express 5 as a ratio of two integers? Sure. 5 over 1, 25 over 5, so yeah. 5. How about 0? Is 0 rational? Can I express 0 as a ratio of two integers?
No. 5 over 0.
Well, that will be undefined. So 0 in the denominator is bad, but 0 in the numerator is okay. 0 over 5 is 0. 0 over everything that's not 0 is 0. Right? 0 over 0 is equivalent. Doesn't equal 1, you're not going to talk about that till like column 2, what happens when you have 0 on top and 0 on the bottom. But for now, yes, 0 is a rational number. I can express it as a fraction. How about things like 0.333 and 3 goes on forever? Can we express that as a fraction? Yeah, that's just your 1/3. So even if your decimal goes on forever, if there is a pattern in that decimal expansion, then there is a way to turn it into a ratio of two integers. It gets a little tricky, so if I write something like this, 7.123 repeated, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I don't know what it is, but there is a way to flip it and make it into a ratio of two integers. Okay? So if there is a pattern, then you got yourself a rational number. And we have a special symbol for the set of rationals, which is a capital Q with a kind of a twist. Okay? So these are the fractions, they go in here, and they just fill in some of the spots. Now the only question is, did we fill this whole thing entirely, or there are still gaps? Or another way to say, are there numbers that cannot be expressed as a ratio of two integers? Or are there numbers where the decimal expansion goes on forever, just randomly, no patterns, just a bunch of numbers for no particular reason? Pi, sure, pi is one of those numbers that has the decimal thing that's just random. Well, it's not random, but it's just, there are no patterns. That's why they talk about listing pi to whatever digits, because it never stops. So yes, there are such numbers, we call them irrationals. Set of irrational numbers. So the numbers that cannot be expressed as a ratio of two integers, the decimal goes on forever. Question?
No, sorry.
Okay. So numbers that cannot be expressed of two integers. But the big way to tell that number is when decimal is just random. There could even be a pattern, but that pattern is just kind of naughty. That probably makes no sense. Let me show you. Let's say you have a number like this, 7.121221222212221. So I'm just increasing the number of twos between the ones. Seems like there is a pattern, there's no repeated pattern. So that would still be irrational. Okay? But yeah, numbers like pi, any combination of pi, if I do something like 3 pi plus 2 over 7, that's still irrational. Okay? there's actually many, many more irrational numbers than there are rational numbers, which is a weird statement if you think about them, because they're infinitely many of both. But they're just more irrationals than rationals. They're much more dense. Okay, there are many, many more of those. It's a different level of infinity, the size of the all the irrational numbers. But then you have your radicals in there, the square roots of 2s and 3s and 7s and 5s. All those square roots are irrationals. And any combination of them, square root of 2 plus 1, that's irrational. The square root of 2 plus every rational number known, that will be irrational. So, you know, we can play that game. So yeah, those things come in and fill in the gaps, the set of irrational numbers. Now your book actually gives the set of irrational numbers a glorified symbol, which is very rare occasion. Usually irrationals don't get a symbol because they're nasty. They don't deserve it, even though we love it. It's enough time. There's also one number, E, that we will learn in this class. That's one of those pi-looking irrational numbers that you need a letter to identify with. But we'll learn it later in the semester. So the big thing, you know, those numbers, are they real? Because we thought that in order for a number to be real, we need to find it on that line. But if that number, you know, has the decimal thing that goes forever and ever, how can you really come in and say, okay, well, this dot right here, that's precisely pi? It's kind of messed up, right? Think about it. How can you know, you cannot measure it, right? You cannot find it on the ruler. But there are ways to build pi. There are ways to build square roots of 2. That's my favorite example. That's the easiest one to do. You can go to your Ace hardware store and ask, give me square root of 2 feet of, you know, this. Just cut it, square root of 2 feet. It'll be very hard to do, but it's possible. Now let me teach you how you can do that. Because if I can cut a stick that's square root of 2 feet long, that means I can put one end of the stick at 0 and drop another end of the stick, and that's where the square root of 2 is. On a number. But the way you do that, if you go to your hardware store, can you ask them to cut you exactly 1 foot long stick? And can you ask them for another 1 foot long stick? For 2. Can you ask for 2 1 foot long? Yes. And then ask them for, you know, a 3 foot stick. So 1 foot, 1 foot, 3 feet. Okay, so you have those 3 sticks, and what you can do, you can take one stick that's 1 foot long and place it like this, so it's 1 foot, and you can take another stick that's 1 foot long and place it like that in a way that it forms a right angle. You can do that. Like, you can shove them in the corner of any room. Here we go, 90 degree, right? Well, then take that longer stick, put one end over here, and then drop it in a way that it kind of connects there, and then just cut it right here. So the question is, how long is this side? Okay. So let's think. You have a triangle that has a 90-degree angle, so you have a right triangle, and you're missing one side, so there's a theorem that helps you. Pythagorean theorem, right? That's the theorem that we like. The one that tells you that 1 length squared plus another length squared equals the hypotenuse squared, right? So in this case, A is 1 squared, B is 1, B squared, C is the unknown, right? So here's an equation. It's not a linear equation because our variable is squared. It's more of a quadratic equation, but we'll get to that later. Well, so what is 1 squared? And what is 1 plus 1? 2. So 2 equals C squared. So what do you think C equals to? Square root, right? So I just built something that's square root of 2 feet long, right? So therefore it's real. That's what it means to be a real number, that I can actually experience, I can touch it. So here we go. And it's a little more complicated with the rest of them, but some of them can be constructed like that. Okay? So it's actually a little history lesson. There are, you know, These numbers were discovered by, back in ancient Greece, by a society that called themselves Pythagoreans. There was a secret society of sorts. But it's ancient Greece, so they believed in the perfection of the world. That, if you think about ancient Greece, what comes into your mind? What kind of images?
Yes.
Yeah, everybody's, Olympics, ugly kids off the cliff.
Yeah.
Well, that's the society that we're talking about. And the philosophy and all that. So they believe everything is perfect, so fractions, that's as bad as it gets. Ratio of two integers, cannot have them squared of two numbers, they just do not exist. And they held that belief strongly. But then they were the ones who kind of said, hey, but look at that, using the theorem named after our society, I just built the square root of 2. So they tried to keep it a secret because, people will freak out. But somebody, true story, I'm not making this up. Somebody said, hey, people of Greece, there are square roots of 2s, and they killed that guy. It's messed up, that's the story. You can read about it. Just Google Pythagoreans, irrational numbers. You'll read the story, you can make a movie about it. But anyway, so these are the irrationals. But notice how before we were saying that, naturals is a subset of integers, right? I can also say that integers will be a subset of rationals, because every integer, like 5, can be expressed as a ratio of two integers. So I can actually say things like this, z is a subset of q, right? While rational numbers and irrational numbers are totally separated. They have nothing in common. There is no number that is both rational and irrational at the same time. Because you cannot be able to, write yourself as a ratio of two integers and not be able to write yourself as a ratio of two integers at the same time. Okay? So these are not subsets of each other in any way or form. But if you put rationals together with irrationals, you get yourself a set of real numbers. And the notation for that, so a set of real numbers, and we use capital letter R to denote that kind of a okay? So again, let's recap. Real numbers, we use R. That makes sense. That's the big one. All real numbers, we use big R to represent as that. Natural numbers, we used N. That kind of makes sense. This whole Z and Q thing starts to fall apart on us a little bit, as far as making sense for choosing the letter I. We're kind of okay with I for irrational, even though I'm not, because I is probably can be used elsewhere more efficiently. But yeah. But anyways, Q for rational, since R is already taken by the real numbers, they used Q for quotients, fractions, quotients. That's where Q comes from. Well, in Z, because again, integer starts with an I, and I is a very in a high demand letter. So they use the German word Zahl. That's how it's spelled. It's German. Anybody speaks German? I don't speak German, I just know that's Zahl. That's how it's. And it stands for something pure and whole, like integers. So that's where the Z comes from. Okay? Is that fun? So that's the structure of real numbers. Now, we will also talk about numbers that are not real in this class a little later. Okay? But that's as far as real numbers go. Okay, good. I didn't get anybody from online to log in. One showed up with. Okay, good. Well, I'm going to let you go early today, and we'll start.